Okay, so welcome everybody. My name is Łukasz Piątkowski. I'm an architect for our managed apps teams. And with the Halo team, we're recently working on the Loki application, which, well, becomes quite popular. So in this short webinar, I'd like to give you a short intro about how Loki works. So we are going straight to business, and I want to keep this really technical. Then I want to focus on two important aspects of Loki, which is how Loki handles authentication and authorization, because there might be some confusion around it, and I think this is really important. And also I will spend just like 1 minute on Promtail, which is like the default and custom-made login agent made for Loki. Then I will tell you a little bit about how our Loki setup works, so how the chart that we have prepared and we would like to offer you works. There will be 1 minute short guest appearance of Linkerd. You will see why and why we think that this is quite a nice idea. And at the end, I will try to save at least 10 minutes for questions and answers. So let's get started. First, Loki itself. As you all know, Loki is for logs. This is a log server. And their headline is Loki is like Prometheus, but for logs. And this is really the best one-sentence summary of Loki I've ever heard. They chose it wisely. The basic idea is that if you're familiar with Prometheus, Prometheus just collects a set of usually numbers and some metadata in a form of labels that are attached to those numbers. Loki does exactly the same, just with lines of text. So it takes your logs, takes lines of text out of them, and attaches labels, so later you can do some operations, search and aggregation based on those labels. One of the biggest advantages of Loki is that it is lighter and should be much cheaper in ownership than the popular Elasticsearch-based stack. The main difference comes from the fact that Loki has a little bit different idea about how to keep the index. So while almost all the other major solutions focus on creating a huge index that involves everything you might want to get from your logs later, Loki really creates a small index that is only used to choose different data chunks, and then that's something that we can basically call a distributed grep to extract data that you need from chunks that you've selected with index. That way, index is much smaller, and the overall operational cost should be also smaller as well. Loki offers hard multi-tenancy. I'll get back to this because this is strictly related to the authentication and authorization process. To put logs in Loki, there are multiple log forwarders, so log agents, so you can use stuff like FluentBit, Logstash, I think already has support for Loki as well. But also it has a dedicated one, Promtail, which is like part of the package, part of the project, and I will focus on it for 1 minute as well. All the queries, when you query for log, are expressed in a language that they call LogQL. Here's a link to doc if you're interested in more details. Basically, again, like Prometheus. So if you know PromQL, you will find LogQL quite familiar. The important thing about Loki is that it attaches labels, but labels are of two basic kinds. There are static labels and dynamic labels, and this is really important to tell one from the other. Static labels are assigned to your text lines when they are fetched by the login agent. Dynamic labels can be created, well, dynamically during the query time. This is quite interesting property, and I will show you one example how it works. Obviously, Loki has great integration with Grafana because they come from the same company, Grafana Labs. And also what is interesting for us, Loki really has a microservices-based architecture where each part of the setup is easily scalable and can run in highly available mode. And because I think this might be interesting for you as the technical teams responsible for running login infrastructure, here's an architecture of core components of Loki. The interesting thing is that there are two completely or almost completely separated paths for accessing Loki data stored in Loki. There's a write path that you see in red, and there's a read path that you see in blue. So basically, for write path, there are login agents, Promtails, for example, that get stuff from your jobs. So they read logs, and then they push it to the first service of Loki, which is called distributor. Distributor is responsible for queuing incoming logs and then talking to ingesters, which are responsible for actually preparing the data for storage and storing them. Important thing is that ingesters need to maintain a quorum among them because they run a hash ring that needs to stay consistent. And then ingesters are responsible for taking data that distributor assigned them, and with that data, they need two storage places. One is for storing index, excuse me. One part is for storing index, so it extracts actually just indexes really because they are already there. The labels that are attached to your logs and stores them in index, and then the full log text is stored in what they call a chunk storage. And then there is a read path, which usually starts with Grafana because Grafana is the de facto standard interface for doing Loki queries. Queries from Grafana go to Querier, and Querier is the thing that is responsible for turning your query into figuring out which index they need to, the queryers need to get. So it fetches that from the index storage, and based on index, they refer chunks, and then they process chunks to return exactly the data you need. Additionally, they might need to consult ingesters for data that is in flight, so that is already accepted by ingesters, but not really yet stored in index and chunk store. This is more like a detail just to explain what this other arrow is doing over here. When you deploy Loki for real, you will find out that actually the architecture is a little bit more complex, and you will find a bit more services running there than just the main three I just showed you. There is a service that is called Query Frontend, which is meant to make querying for queryers more efficient. So it handles stuff like caching, splitting your queries, ordering your queries, and managing the query queue to not overwhelm the queryers. There is one more service called Compactor that is neither in the write or read path. Its only task is just to go over the chunks, so blocks of data, blocks of logs stored in the persistent storage, and pack them to the fullest to make the chunk storage more efficient. So this helps with both performance and with storage cost. There's a component called Gateway, which is just that, an Nginx that is depending on whether you are pushing your logs, so using the write path, or reading your logs, so running queries, just takes the URL and pushes the request to the correct service in the overall Loki application. And there's one more interesting component that is called Ruler, which is pretty cool because Ruler is, again, like in Prometheus, you drop a query and a trigger level for this query, and your query is executed constantly over the stream of logs. And if the rule and the trigger level match, there is an alert triggered, and natively Loki supports alert manager, exactly the same alert manager that basically everyone uses with with Prometheus. And you can use the same alert manager. It is API compatible, and Ruler is your interface for that. As you probably already guessed from the picture, there's no single point of failure. The only requirement really is that you always have a quorum of ingesters. So more than a half of ingesters need to be available. Great thing is that other than that, each component in the architecture can be scaled independently. So depending on whether you need more read throughput or write throughput or something different, like for example, compaction, wherever you miss performance, you can scale only this single service, this single component. One of the most interesting things that is included in the 2.0 release is how they simplified the storage requirements. Previously, for index and chunks, you basically for index needed some form of document database, and for chunks, it depends. But since 2.0 release, basically, you can keep everything, including index and chunks, in something as simple and as cost-effective as just S3 compatible storage. Now, I told you that one of the problems is around Loki authentication, and it might not be really a problem, but it is an assumption that they did for Loki. And basically, it means that Loki doesn't do any authentication. Loki does support strict multi-tenancy. By strict, I mean there is no cross-tenants data access ever. So once tenants are separated, they are separated for good. And there is no additional in-tenant data isolation. So once you're part of tenant, you can read and write everything that is accessible and stored for this tenant. Now, obviously, it means that it doesn't, well, it might not include authentication, but we need authorization. And the thing is that the whole authorization mechanism is that each of the HTTP requests that is headed to multi-tenant Loki is expected to have a special Xscope org ID HTTP header. And that's it. The value of this header, the ID included in this header, matches, is the only match that Loki does between the request and the tenant that you will access. So both log shipping, like Promtail, and querying agents need to set this header, but Loki doesn't do any authentication. It means that whoever sends a request with this header set to specific value is considered to be part of the indicated tenant. This means that we have to extract the problem of enforcing the org ID header and authenticating external header to the external component. And this is partially solved by the gateway component, which provides just additional HTTP authentication, so it can do like HTTPS offloading and then basic auth. But still, there is that limit that currently there is no matching of authenticated users, so like with basic auth, with the value of org ID header. So an authenticated user can send any value of the header. It is not checked one against the other. We know about this. This is obviously a shortcoming. We already have some ideas how to solve it, but we are not done yet. Just a few words about the Promtail agent. It is a really flexible and Loki dedicated log forwarding agent, which again works very similar to how getting data by Prometheus from Prometheus data sources works like. So if you're all familiar with rewrite rules and matching rules and everything that goes for Prometheus metrics, that's the same. So you can use Promtail to configure, to filter, rewrite, add, remove static labels for your logs, but also you can check and change the log structure. Also, Promtail can be responsible for setting your org IDs or your tenant ID. And what is important, not that obvious, you can run multiple copies of Promtail in parallel. So if you want to separate your logs, for example, into two organizations, or you want to, I don't know, push one part of your logs to one Loki instance and another part of your logs into another Loki instance, you can all do that all either by a valid configuration of a single Promtail agent, but if it's not possible, you can run multiple instances in parallel, and this should all work and allow you to do even more complicated forwarding scenarios. What's important, Promtail has support for parsing both structured and unstructured logs. I'm not sure where does it come from, but multiple times I have heard that Loki is not a good solution because Loki doesn't support unstructured logs. That's totally untrue. You can still get unstructured logs, although there are some very clever and nice helpers for structured logs. But a picture is worth 1,000 words, they say. So just a short show. Over here, you can see static labels, right? Like app, cluster, and component. Those labels were included ingestion time by Promtail. But then I have a line like over here, just a single log line entry that is definitely unstructured. I mean, it's not JSON YAML or something like that, right? And I want to query for a specific query time. So have a look above. I made this very nice regexp especially for you. The first part of the query before the first pipe means that we want to filter all the log entries and choose only those that have label apps set to value Loki. So we are querying Loki's logs themselves. And then I pass them to a regexp where every named capture group in my regex, regular expression, means that I'm creating a dynamic label. So with this first part, with red underscore, I'm creating a log level dynamic label based on this capture group. And then again, I'm doing the same for duration. I'm creating dynamically a label called duration, and there is a regex that captures that duration. What is really cool, you can again have a look below, that this log level and the duration things, they're already listed as labels, the same way as if they were created the static way by Prompter. But this time I got them dynamic based on my query. What's even better, if you look back up into the query itself, there's another pipe, and then I can use those dynamic labels for all the kind of comparisons at whatever not. So for example, even though the duration was a text that I just parsed with regexp, I can already do a query and select only those log entries where the duration field has bigger value than 0.2 millisecond. So you can definitely do unstructured logs, and also you can see here what is the difference between static and dynamic labels. Now, just a few words about our Loki chart and recommended setup. So just two notes. Please note that we were playing with Loki for quite some time already, and there's a Loki Stack app in Playground. This is not the app I'm talking about right now. This is an all-in-one demo quality only Loki. The one I'm talking about over here is the Loki app in the Giant Swarm catalog. And also please note that, yes, as I already said, this Loki app still has some shortcomings. Don't run it in production yet, but we believe it is already good enough for testing, learning, evaluating, and so on. And we are working on the shortcomings. Now, the default choice of configuration options we've made for our Loki, we're using the embedded BoldDB database as our index database. It means that this can be stored in S3. So basically, this BoldDB database is completely invisible for us. For us, it only means we need to give Loki an S3 storage. And our chunks are stored in S3 storage as well. This means that there's only one really efficient and cheap storage that we need for Loki, which is S3. We have included gateway and compactor in our default setup. I told you about them in the architecture part. Requirements you need to fulfill to be able to run it. Pods that are created by Loki need to be able to access the configured S3 storage backend. It's pretty obvious, but it might be not that easy to configure. We have tested this setup on both AWS and Azure. We have some docs about how to set up the necessary infrastructure part for it. You should need at least 3 or 4 worker nodes in your cluster to run all the components. This should be enough for any medium-size setup. Well, might be bigger for bigger setups. And even though the main persistent storage is S3, you still need some local instance storage, mainly used for caching. And the important thing, it can forward not only your Kubernetes logs, but also system-level logs. Limitations and a short summary. We have this org ID header thing I already mentioned. You should know that we still need to set up monitoring and alerting. And we have some shortcoming also around how Loki forwards logs from systemd, journald specifically. There's something wrong on integration between them, and we still need to figure out why. Anything else? Please ping Cedric from our team, our SE, or SE assigned to your company if you want to try, deploy, or learn more. Now, I promised you just a short appearance of Linkerd. So as you probably know, Linkerd is a pretty light service mesh implementation, which is very easy to use. Doesn't require any custom CRs, doesn't require any specific setup. The important thing for us is that you can get observability of HTTP traffic for free. It is very fast, and you can also get MTLS for free. And these were the main 3 reasons why we wanted to deploy our, test installation of Loki with Linkerd, because, well, this involves very little, there is very little involvement with us. It is really easy to set up. We'll get a great observability of what is going on because all the microservices that Loki runs are HTTP, so we can track them live. And also we get automatic MTLS, so basically TLS point-to-point for all the Loki services. This is how it looks like in practice. You can see that we have our Loki components and we can live monitor performance, success rate, and such. Obviously, this component is not necessary. We just think that it is a nice match, but you definitely don't have to run it. That's it from my side. Thank you for listening and being here. And if you have any questions, I'm happy to answer them.